Good evening, sir. I am Arfrahan. I'm gonna present now my project on wine quality prediction. It's based on deep learning and also using the Keras API. First of all, our whole goal is to maintain the chemical aspects of the wine, and it comes after fanning and distillation. Because before bottling, we need to ensure the perfect ratio for different type of malt and different type of taste. And that's why in the alcohol industry it's a big deal to actually manipulate this, or should I say control this whole affair within from a decentralized process, or more like a enforcement learning process, so that the machine can take the toll that the humans don't need to do, and that saves our money and also helps us a lot in achieving better betterment in the industry. First of all, we have used the data for the chemical composition of red wine, and this is here in the my draft folder. And here we can see different type of chemical terms here and the ratio of them. Some of them are in ppm, two of them are in percentage, and there is also one for simply logarithmic number. I mean pH, and also the quality and alcohol, and these are like index more according to man-made standards, not like in scientific basis. So first of all, we are gonna retrieve some columns and gonna cite them through the dataset. And finally, we can show from the dataset, we can show the graph of relative fixed acidity of white wine. Uh, the acidity is a huge factor in wine, because the acidity actually determines how long you can preserve the wine. For red wine, the acidity actually means how long you can preserve the wine. So we need to address that. And also there is a graph that comes from plotting through our data set, and it is fixed acidity versus quality index. Quality index is based on the business representatives. And also, when the graph looks pretty dissimilar, because the quality doesn't drastically change according to fixed acidity, because there are some other factors also, because acidity can be neutralized by a different type of chemical element, which I will talk about later here. Then we are going to citric acid. This is not as important for the preservation and stuff, but this is more important for the taste, and for especially for the possibilities for food poisoning, or having some physical disorder or physical what should I say, discomfort after drinking alcohol. There are some people who are pretty allergic to too much citric acid in their alcohol, despite being a good drinker. So the next one is residual sugar. It's actually based on health index, not necessarily a chemical composition. We have used the chemical composition from the dataset, but the health index in the bar, because of our the unit measurement. Yeah. And then we go to the chlorides, and then we have sulfates, which are not also important, also sulfate. But the important thing is free sulfur dioxide, and also the carbonated sulfur dioxide, because sulfur dioxide actually generates from every type of fermentation. And since alcohol is actually a like huge summation of a lot of fermentations happening simultaneously, so we need to control the free sulfur dioxide. There are two indexes. Free sulfur dioxide is for actually for environment purposes, to actually calculate or to have a track of how much sulfur dioxide actually are they are emitting, because it's actually a pretty harmful substance for our environment as a whole. And about the other sulfur dioxide, the conjugated, that is for health purposes, as also for the drinking purpose of the alcoholic industry. And next we are going to the equality index, and also we can plot the whole in a heat map with several axes, and we can get all through this the pH, the sulfates, and every chemical properties here. This is a pair plot of that data. Then we are gonna assign quality to the fixed values using using level encoder, and also some libraries from python. And the next one is the count plot data quality. It's more of a like comparison between the standards, uh, because you need to actually address the business side of the things as well as the chemical and scientific aspect. Next, we are going to train our data set to actually get a sample and predict the quality of the wine. So this is our model that comes from a standard scalar, and we are gonna train it to first the logistic regression model. Using the logistic regression model, we actually we actually use two variables and also take data from only one single wine bottle, and then we actually like several substances, and then we actually predict the model, and it comes up its accuracy is kind of good. It's 72.25% nearly. Yeah, but there are some better methods. There is SGD classifier is also a old method, but it is actually quite less than the logistic regression one, so it also disqualifies. Then we have okay, then we have okay, okay, I was skipping this. This is the SBC model, and its accuracy is also 73%, so not necessarily a huge improvement. Then we go to decision tree classifier, and that also doesn't give us the good result. But then when we do random forest, the accuracy actually jumps up to 78.25%, because we are actually fitting the model to implement the random forest algorithm there. And also the classification reward and confusion matrix has a quite good similarity, because the precision fast read and also the after chemical reaction read doesn't actually differ that much. You can see here that 0.7, 0.78, the scores are not defining that much. That means the alcohol fermentation has been done in a quite nice way. And then we can evaluate the scores. And there is also another method, but it is not quite as good as the random forest one, but it still gives quite 75%. Also the training accuracy is actually really good, 94%, but the testing accuracy is kind of where it gets behind the random forest one. And also finally we are going to use the really really well known and well used that Keras API for our sequential model. And then with that model we are going to predict the quality of the wine. So this was our deep learning model for predicting the quality of wine. uh, Thank you, sir.